So in the description for this video, you can find a link to this code that will generate a randomized forest terrain map for use in your tabletop role-playing game of choice, be it Dungeons and Dragons, Pathfinder, Tavern of Heroes, Shadowrun, whatever your game of choice is, you need maps. And sometimes you need a random map, and so that's what this does, is it generates a random map. You get to specify what properties you want the map to have up here. So you can specify a minimum number of trees. So you obviously want some trees in your forest. So there's the minimum number of trees. You then specify the maximum number of trees to avoid, having your forest too crowded. You can also add in some stones for your PCs to have to crawl over or climb over or jump on top of. So this is the minimum number of stones and maximum number of stones. You're of course welcome to set both of those equal to 0 and leave the stones out entirely. And then you have to specify the range of sizes you want for the stones. So are these large stones? Are they big boulders? Are they, basically small little platforms that show up? And this gives you a range for that. The units for this is number of squares on the grid here. So right now we've got anywhere between 0.5 and 1.5. So all of these stones have a width somewhere between half of a square and 1.5 squares. The next option is whether you want there to be a river, which of course you want there to be a river, so the default is set equal to true. But if you decide you don't want a river or stream or rivulet or whatever you've got going on in your forest, if you don't want any body of water, then you just say false, and this little blue ribbon here will go away. And here, if you do want a river, this is where you can specify the minimum river width and the maximum river width. Again, that's measured in squares. Actually, I should add that as a note up here for the stones, maximum width of stones in squares and squares. There we go. Just since you sometimes have that ambiguity in RPGs between number of squares and number of feet. So this river is going to be anywhere between 1 square wide and 3 squares wide. So that's where you can see the river kind of closing in on itself. So it's getting a little bit narrower here, getting a little bit wider there. So that's at each point, your river is going to be some width between those two values. And then you can specify how many squares your grid should have. You can give it a width and a height. I gave 20 by 13 because I believe that's the dimensions on the map I use. And then you shouldn't need to change anything below that. You just click run up here. And you get a different map. So this is a very different map. It's got the minimum number of trees. It's got a much larger rock-to-tree ratio, because so I'm kind of envisioning this as more like the edge of the forest before it gets to the rocky clearing or the foothills of the mountains, and the river's going in a different direction. So each one of those elements is randomized in the code. Here's another example with one more tree. There's a tree growing in the middle of the river here. That's something I need to figure out how to fix. But I suppose you could have a tree growing out of a small island in the middle of the river, or you can just ignore the tree when you're drawing the map, right? Because you're just generating this right before your encounter to have a map to place in front of your players, and so you can omit that tree there. So if that's all you want to do is just run this thing, then that's all you need to know. Let's spend a few minutes going on to how this code works. So let's see, the first thing we do is we make this grid. That's pretty straightforward. Basically, you're looping over each of these possible points and using VPython's curve object to create the lines in the grid. Here we get to the river. Now, this was an interesting process. So the river, the thickness here, that's just the thickness coming this way. If you right-click, you can actually rotate this thing and see that all of the forest elements are underneath the grid. So I've placed them all slightly below the grid, but they've each got to have a thickness there. And so here we select a random number to determine, basically we flip a coin to determine whether the river begins and ends along the horizontal edges or along the vertical edges. So is it going slashing through like this, or is it slashing across like this? And then once we have that, we have to pick the beginning and ending points of the river. So that's this X-min, X-max, Y-min, Y-max. That's basically these 1, 2, 3, 4 corners here. And then we turn those into coordinates here with lower left, lower right, upper right. And so depending on where you start and end, there's different ways of calculating those. And then we just create the perimeter of this river shape. So this is basically a polygon with a series of points that determine where these little corners are. And those points get set up here in this, in these couple of for loops. One does one side of the river, one does the other side of the river. And essentially you're choosing you're randomly determining whether the river bows inward or bows outward. Basically, does it get narrower or wider to just give it a little bit more of a realistic feel. And then here in this second half, we have the river beginning and ending along the horizontal edges. It's much the same setup as before. We just have to work out the geometry a little bit differently to guarantee it starts and ends at the correct edges. So all of that process creates this outline for the river. Then to actually make the river, we use VPython's extrusion function. This basically says we're going to take the shape of the river and then extrude it down into the screen a little bit, or excuse me, up into the screen a little bit to give it that thickness in the Z direction. Next, now that we've got some water, we can make some trees. So here we select a random number of trees. So we're picking a random integer between the minimum and the maximum. I've got rand between defined somewhere below here. Yeah, right here we've got random between there. And then we're chopping that off to make an integer for the number of trees. Here's where we turn that into an integer. And then we just create each of those trees one at a time. This is where I tried to tell whether it was in the river. And so that obviously is not working because I've got trees growing out of the river. So I need to work on the logic for that part. But like I said, just, ignore the trees in the river for right now. So here we pick random coordinates for the tree. There's an X tree and a Y tree. This is where I'm trying to check for whether it's in the river. It's currently not working. So, I need to make an adjustment to that. So we'll just skip over that for right now. Here's where we determine how many circles the tree is made of. So each of these tree shapes is just a number of circles clustered together around a common point. You can see, for example, that this tree is made of 6 circles, while this tree is made of 5 circles. This tree is made of, looks more like 8 circles. Nope, that's another 6. Excuse me, that's another 1, 2, 3, 4, 5, 6. This just got a bigger size. This one's made of 4 circles. And so basically you go between 4 and 6 here to get the number of circles that it's made of. Then we select a random width for our tree. And then basically we create these circles around evenly spaced so that you have kind of a pentagon-shaped tree here and a hexagon-shaped tree here, but it's rounded out because it's trees, obviously. It needs to be rounded out with all the branches. And so each one of those circles is created using VPython's cylinder option. And then lastly, we make the stones. This is much the same process as the trees. We select the number of stones here using our random number generator, and then we loop over each of the stones, try to keep them out of the river. Again, not working. And here we just we create the stones again using a cylinder, and I'm rotating the stones by a randomized angle so that they're not all, like these 3 are a bad example because they're all kind of organized the same way. This one's a good example. This one got rotated, this one got rotated. So, that we have a little bit of randomness to the map that you are that you're working with. So that's my RPG Forest Map Randomizer. You can access it at the link in the description below, change the numbers at the beginning, and even change some of the logic in the middle if you want to. And you too can create these random maps for your RPG encounters. Thank you so much for watching. I will see you next time. Bye-bye.